Let's continue with two more parts of exercise 118. We have already solved two and today we are going to see two more. So let's first recall what it was all about. We have a ring homomorphism F from the ring A to the ring B. And A has these two ideals I1 and I2 and B has J1 and J2 as its ideals. Then the extension of the intersection of I1 and I2 is contained in, that means is a subset of the intersection of their extensions. There is another one we will see that involves J1 and J2 and that's why I mentioned them as well. So we start the solution with these containments. Because I1 intersection I2 is a subset of I1, so the F image of I1 intersection I2 is a subset of the F image of I1. But the F image of I1 itself is contained in the extension of I1. Why? Because the extension of I1, this thing, is the smallest ideal of B that contains F of I1. That means it contains F of I1 after all. Okay, so that way we find that the extension of I1 also contains F of I1 intersection I2. Similarly, F of I1 intersection I2 is also contained in the extension of I2. That is because you can write F of I2 here, which will itself be contained in I2 extension. So this F image is now contained in both I1 extension and I2 extension. So it is contained in their intersection. Now, what can you say about this intersection? Each extension is an ideal where? An ideal in B. So their intersection is of course also an ideal in B and it has the property that it contains the F image of I1 intersection I2. And what is the definition of this extension of I1 intersection I2? It is thus this thing. This is the smallest ideal in B that contains F of I1 intersection I2. And this is some ideal in B which contains F of I1 intersection I2. So this smallest nature of this extension makes it a subset of this. Some other ideal may be equal, may not be equal, who knows. That is why we simply have inclusion, not necessarily equality. And next we have this equation. This time we have equation involving the ideals J1 and J2. And because we are talking about ideals of B, so now we can think of contraction, not extension. The contraction of J1 intersection J2 is equal to the contraction of J1 intersection the contraction of J2. This one is very easy to prove. Let's see. So the solution is a very short one. We straight away take this one, the contraction of J1 intersection J2, which by definition is just the inverse image of J1 intersection J2 under F. And you know that inverse images behave well with all the operations, all the set operations. In particular, inverse image of intersection is equal to intersection of inverse images. So that's how we get F inverse of J1 intersection F inverse of J2. And this again by definition of contraction is just J1 contraction and this is J2 contraction. That's it.